Hello everyone. So we will be in this class we will be starting with finite difference method. That's nothing but unit number 5. Most of the problems in structural mechanics involve differential equations of the ordinary type required for determination of the moment, shear forces and deflections in beams and buckling of the columns. Actually, you might have seen slope in case of beams, deflection finding in case of beams, and beam. Also, we have seen columns and strut. Okay, you have studied in strength of materials. So there we used to use d2 over dx square is equal to m, some equation we were using, right? So almost in all the structural mechanics problems where deflection involved, so we will be using those differentiations, okay, differential equations. So in order to solve those equations, partial differential equations are necessary, are invariably required in solving those problems. Even in the case of two-dimensional structural element problems like bending of plates and the solution of vibration problems, these partial differential equations are essential. Okay, it is required to use. So for these kind of problems, direct solutions can be possible only if the load distribution, sectional properties, boundary conditions are easily represented by the mathematical expressions. Okay, so they have to be very simple. Sectional properties should be very simple. Boundary conditions should be simple. So then only we can make use of this partial differential equations, and so we can solve the problem. But for complex problems, okay, or complex problems involving complex loading, complex boundary conditions, and different variable cross section, or there may be variation in the cross section. Okay, so in that cases, exact solutions cannot be obtained by using these partial differential equations. Okay, so we need to use some numerical methods to solve such kind of problems, and that method which will be used will be called as finite difference method. Okay, and it can be very advantageously employed to solve such kind of complex problems. Okay, so in finite difference method, what we will be doing is at each pivoted point of the intervals, just like we did in case of previous problems, we will be dividing the given continuum into number of pieces. Okay, and then we'll try to apply this numerical method. So here also we will be considering a number of pivotal points. Okay, and at each pivotal point, an equation expressing differential equation by the finite differences can be established. Okay, so we will proceed further, and you will understand later, okay, what it will be and all. So then, so an equation expressing the differential equation by finite differences can be established. So you will be getting the equation at each interval. Okay, so which is in terms of differential, finite difference. Difference you will be calculating for each interval. Okay, and a set of simultaneous equations are developed. Okay, a set of a set of simultaneous equations are developed, and they are solved using boundary conditions at the pivotal points. Okay, the computation can be easily handled mechanically by using calculators or digital computers. So what you will be doing is you will be dividing the, so let us say for example there will be some equation. Okay, there will be some a line which is having some f of x. Okay, so variation, it is not defined, it is very complex variation. So this variation can be expressed, okay, by using some function And in terms of the differences, what you will be doing is you will be calculating the difference between the previous value and so you can see here delta n is there. So this delta n is the difference between yn plus 1 and yn. So that will give you yn, delta yn. So likewise you will be calculating the differences. These are called as finite differences. Why it is finite differences? Because it is calculated between two finite points. Okay, so you'll be calculating finite differences, and those can be expressed in terms of equations, simultaneous equations. You can get it at pivotal points. Okay, and solving those pivotal points, you can get whatever unknown which is there. Okay, so this is what finite difference method will be. Okay, next, expression for derivative by finite differences. Okay, so here, as I said, let us consider some line. Okay, some expression where you will get some complex line, which is nothing but delta y is equal to f of x is the line equation for the line. So here the value y is represented by f of x. Okay, so therefore, and the derivatives of y is equal to f of x will be dy by dx, and the second derivative will be d2y by dx square, and the third derivative will be d3y by dx cube. It will become, right? So likewise there will be derivative. Okay, now, so referring the figure, the rate of change of y with respect to x at any point is written as, so this is actually the formula, this is the equation, line. So rate of change of y, okay, how exactly it is varying, so that can be written as delta y by delta x. We know here, so let us consider this difference between each interval. Okay, our distance between the two intervals is, let us consider it as delta x, and let it be equal to h. Okay, as we do in the previous cases. So let it be h. Therefore delta y by delta x, okay, can be obtained by this delta y by delta x can be obtained by y. So you can see here, you can get an equation that this can be calculated as delta yn plus 1 minus delta yn, yn plus 1 minus, you can see here, yn plus 1 minus yn divided by h. That, so everywhere, okay, here I have shown here. So similarly you can represent the variation here, even here also. Okay, you can get it like here, and this can be considered as yn, delta y and delta x. So the variation, the difference between that delta y by delta x can also be calculated by this difference. Okay, this delta y is nothing but yn plus 1 minus yn divided by delta x is equal to h, or it can also be calculated here as well. So yn, this is yn minus yn minus 1, so that is the difference. Okay, and you can calculate here as well. So this is delta y. So delta y is equal to this is actually delta y. Let us consider as delta y. So delta y, and this will be delta x. So delta y by delta x is equal to this difference. This difference can be obtained by either between these two or between these two. That is what it can be. So here the value can be given by delta so yn minus yn minus 1. So this is actually this is yn minus yn minus 1 will give you delta y. So that delta y divided by delta x will give you the rate of change of variation of y. So this delta x is equal to h. Therefore yn minus yn minus 1 has given you the value, and divided by h will give you delta y by delta x, okay, at any point. Next, that is actually the first derivative. The next, second derivative will be given by delta y square, delta square by y, delta square y by delta x square is given by the formula, the difference between those two you can get. Okay, So yn plus 1 minus yn, that is the difference, divided by h will be there, into one more h will come, because this is delta x square, right? So the difference between these two minus of this, okay? So that is actually the second order differentiation, derivative. So difference of differences, you can see here, this is the difference between, this will give you actually delta y, okay, delta y, let's say it can be delta yn, so minus of one more delta, so that difference, that is actually the second order, delta y minus delta something, right? So that is called the second order value, and if you calculate that, simplify it, so it will come delta yn plus 1 minus 2, because here you will have 2yn, so 2yn plus yn minus 1, so this is actually y minus 1, yn plus 1 minus 2yn plus yn minus 1 divided by h square. You can say, take this as LCM. So you can call this as, let us say, delta yn plus 1 minus delta y, okay, delta yn. So that difference will give you actually the second order differentiation, okay? So difference of difference. So this is actually first difference, and difference of differences. So that will give you second order differential equation. So this, by using the different sets of points, the finite differences at any point can be expressed in three different ways, such as, so this is how we will be calculating the differences at higher levels, okay? This is first order differentiation, second order differentiation, okay? And because we are doing at finite points, this method is called as finite difference method, okay? So that's all the difference here. Now, so there are three different methods to calculate these finite differences. So the first one is backward differences, next is forward difference, and central differences. Let us consider backward difference method. So in this backward difference method, what you will be doing is, you will be considering an equation, equation, and let y1, y0, y1, y2 up to yn minus 3, yn minus 2, yn minus 1, and yn. So let those be the values. Now in backward difference method, what you will be doing is, you will be calculating the backward differences, okay? Because it is a finite difference method, all those differences we will be calculating starting from the highest value and in the decreasing order. So highest value will be yn, next yn minus 1, yn minus 2, like that. So like that, this will be the first order difference. First order difference yn minus of yn minus 1, okay? That is called first order difference, and that value will be delta y, right? In the second order difference, what you will be doing is, we will be having a delta y value and delta yn minus 1, delta yn minus 2, delta yn minus 3, okay? So those values will be having. So that difference will give you the second order difference. So here you can see the difference between yeah, 1 second, yeah, here. So what we'll be doing is, okay, yeah, I think I see, I kept the sheet below. So you can see the second order difference will be obtained by delta, you will calculate delta yn, delta yn minus 1, delta yn minus 2, delta yn minus 3. So the differences of delta y will be the second order difference. So delta yn minus delta yn minus 1 will give you delta square yn, okay? So similarly, you can get the difference here. So delta yn minus 1, right, minus delta yn minus 2 will give you delta yn minus 1, just like that, okay? So we will be calculating from the highest value okay, and backward. That is called backward differences. So here now let us have, so what do you need to do? You can calculate delta yn is equal to, here you can see here, delta yn is equal to yn, that's nothing but here yn, okay, minus of yn minus 1. You can see here yn minus of yn minus 1 will give you delta yn, okay. Next, delta yn minus 1, what it will be? Delta yn minus 1, here delta yn minus 1, this difference can be obtained by delta yn minus 1, yn minus 1 minus yn minus 2. That this difference will give you, difference of these two will give you delta yn minus 1. This is backward difference method. So we will be considering the highest value minus the next lowest value. Next, so that's how we will be calculating the first order difference. Next, second order difference. How to calculate the second order difference? I'll let you know here. So in order to calculate the second order difference, so we will be having, you will be representing the delta y values, okay. Delta y, you can start from delta y0, delta y1, delta y2, just like that, and up to delta yn, okay. Delta yn you will have up to delta yn, you can see here, right? And you can now from that delta y, what we will be doing, we will be in the decreasing order, we will calculate. So delta y square yn, delta square yn, how do you calculate delta square yn? That's nothing but the difference between these two. Okay, you can see here delta yn, okay, delta yn minus delta yn minus 1. So that difference will give you delta yn, so delta square yn. Next, okay, so that can be represented by delta yn minus delta. So you just substitute the value of delta yn here, delta yn and delta yn minus 1. That will give you yn minus 1 minus yn minus 1, yn minus 2. So if you calculate it, so this is, there are two values of delta yn minus 1. So yn minus 2, yn minus 1 plus yn minus 2, okay. So this is the second order derivative, or second order difference. Next, the third order difference, similarly you can obtain. I'm not drawing the sketch here, okay. So similarly what you can get, delta cube yn will be equal to delta square yn minus delta square yn minus 1. You can substitute those values, you can see here. So yn minus yn 2 yn minus 1, this is the one, okay. This is the equation, yn 2 yn minus 1, yn minus 2. Similarly, so next lower level values will be yn, instead of yn minus 1, instead of yn minus 2, yn minus 1, yn minus 2, yn minus 3, you will be using yn minus 3. So difference of that will give you the third order difference. And similarly the fourth order difference, delta yn cube, okay, delta cube yn minus delta cube yn minus 1 will give you third order difference, the fourth order difference. So fourth order difference is equal to difference of third order difference, okay. So just you substitute these values here, go on substituting, you will get final equation yn minus 4 yn minus 1, 6 yn minus 2, all these things, okay. So there is a complex calculations which are being involved here. So in order to make it simple, what you can do is, you can have this kind of figure. So you represent delta, y, delta y, so this is y value, first order difference, second order difference, okay, third order difference, right, fourth order difference, like that. So now, and this is x-axis, and next yn, maximum value, yn minus 1, yn minus 2, yn minus 3, yn minus 4. So what you need to do is, next level over here, you can see the difference of yn and yn minus 1 is delta yn. The difference of yn minus 1 and yn minus 2 is delta yn minus 1. So just like that. So from these two difference, you will get first order derivative. Okay, first order difference. That's nothing but delta y. Next, difference of these two will give you second order difference. So in this, okay, representation figure, you will understand very clearly what are those first order difference and second order difference. So these are the y values. Okay, the difference of this will give you first order difference. Okay, delta y values. The difference of these differences will give you second order difference, which is nothing but delta square y values. Okay, so that is what we are representing here. And similarly, next, the difference of these differences will give you the third order difference, and difference of these third order difference will give you fourth order differences. So all these are actually differences calculated at a fixed interval. That is why this method is called as finite difference method. Okay. So now having this chart, so you can get these final equations. Okay, whatever these final equations are there, you can get directly without any difficulty. This equation and this equation and this equation and also the last one, this equation, you can get without any difficulty. I'll let you know how. So in what you need to do, you just need to remember these values. Okay, what you do, plus you multiply here. Okay, so here, so over here, this is the chart. Over here, what you need to do, you just write down delta, these values. Okay, delta yn, delta square yn, delta cube yn, delta to the power 4 yn. You just write down those. Now if you want to get delta yn values, what you need to get, what you need to do is, you write down these plus 1 minus 1, plus 1 minus 2, plus 1 minus 3, plus 3 plus 1. Okay, and this has to be written yn minus 1 along yn minus 1, then the next one will be yn minus 2 along that, then yn minus 3, these values you should write, yn minus 4 you should write down these values. Okay, so delta y3 delta 3 yn, delta cube yn is nothing but 1 minus 1 plus 3 minus plus 1, and delta to the power 4 yn, there you need to write plus 1 minus 4 plus 6 plus 4 plus 1. Okay, see, you can see here values have been increasing. You start with plus 1, next is minus 1 here for yn, next minus 2, next minus 3, next minus 4. Okay, and here, because delta square yn, delta yn will stop at with the two values only. Okay, so yeah, one more value will be there. This is actually plus 1 will be there here. Okay, no, plus 1 will be there. So it should be so you will be starting here plus 1 minus 1, next plus 1 minus 2, plus 1 minus 3, plus 1 minus 4. Because here three terms will be there, you represent it, this should be symmetrical one, plus 1 plus 1. Next, so here and the next for the delta 3 y cube, so plus 1 minus 3 is there, so reverse it should be plus 3, and but the last one should be plus 1. Next, plus 1 minus 4, next value you need to write for the third value plus 6, and here minus 4 plus 4 it will become, and the last one will be plus 1 only. Okay, so this is how you should remember this scheme. Now you can write very easily. I can show you how easily you can write delta yn value. You can see here delta yn is nothing but yn plus, that's nothing but plus, minus, this is because this is 1 minus 1 into yn minus 1, that's nothing but yn minus 1. Next, if you want to write the second order differentiation, I mean difference, so that's nothing but plus yn minus 2yn minus 1, you can see here. Next, plus yn minus 2. Next, similarly, delta 3 y cube, delta cube yn can be obtained by yn, you can see here yn, next 3yn minus 1, next plus 3yn minus 2, next here plus, this is actually plus yn minus 3, because you can see here y plus yn minus 3. Okay, so plus yn minus 3. Similarly, you can write the last equation, which is nothing but, you can see here yn minus 4yn minus 1, Next plus 6, you can see here, plus 6 yn minus 2. Next plus 4, this will become plus actually, plus 4 yn minus 3. Okay, next plus yn minus 4. Okay, that's how we will be calculating the value of the first order, second order difference, third order difference, and fourth order differences. Understood, right? This is called backward differences. Okay, next let us consider the forward difference method. Right, in this forward difference method, only change or only difference between the backward and forward here is we will be considering yn plus yn, then upward. Okay, this is not, yeah. So in forward difference method, we will consider starting from yn. Okay, we will consider the lowest value as yn, and the increasing values, whatever is there, we will be considering those values for calculating the differences. Okay, so same way, what you do, you represent y, delta square y, delta cube y, delta to the power 4y. Okay, so you can see now the difference yn, delta yn, you will calculate from the highest value minus the lowest value. Actually here we will be considering increasing, we'll be considering in the forward direction. We will be going in the forward direction. Earlier we had considered the lowest value, highest value. From there we decreased the values. Now you will be considering this as the first value. You consider the increasing values of these y. Okay. So now if you consider delta yn and delta yn plus 1, so the difference between these two will be delta yn plus 1 minus delta yn. Okay, so that's how we will be considering the highest values, and we will be minus of that you will be doing it. That's what we have to do it in forward difference method. You consider the lowest value as the starting value, and next values you have to consider from there. So the rest of the procedure is same as the previous backward difference method. Okay, so here now you can understand, you can see here delta yn. So delta yn is equal to yn plus 1 minus yn minus yn. Okay, next delta square yn will become delta yn plus 1 minus delta yn. Okay, that is nothing but yn plus 2 minus yn plus 1 minus of yn plus 1 yn. Okay, so that value will come to yn minus 2 yn plus 1 yn plus 2. Okay, so similarly now what you can do is you can go on considering these values, next value delta. Okay, you can same way you can draw this table figure, and from that figure we can go on calculating the value. So you can consider now delta yn. Okay, so yeah, delta y we had obtained. So delta square y, how to get this delta square y? I'll let you show you here. So delta square y, so you'll have these same table. Okay, same values will be there here. Okay, so you can see here yn delta square y, yn minus 2 yn plus 1 plus yn plus 2. Okay, next you can come here for delta cube yn, for delta cube yn. So you can see you can use these coefficients, multiply with yn minus 1, yn plus 2, sorry, yn plus 1, yn plus 2, yn plus 3, yn plus 4. You can see here. Now delta cube yn minus yn, okay, plus 3 yn plus 1. Okay, next plus minus 3 yn minus 2 plus yn plus 3. Okay, so that's how we will have to get delta cube yn. Okay, so similarly you can consider delta to the power 4 yn as well. Okay, so same table which was used earlier, the same thing you can use here. okay, and calculate, right? Next, central difference method. So in the central difference method, what we'll be doing is, in order to calculate the difference at one point, we'll be considering 2 points symmetrically under the about that point. Okay, let us say if you are calculating delta yn here, that means difference at this point. So what you will be considering is the ordinate next to it and the ordinate before it. You consider them, you calculate the difference of those two values, okay, and that divided by 2 will give you the difference over here. So for example, now in order to calculate so delta yn, so in order to calculate delta yn, so delta yn is equal to yn plus 1 next to it, okay, ordinate next to it, next minus yn minus 1. So that actually gives you two differences, right, from here to here, double. So that divided by 2 will give you, it makes single, okay, single difference. So therefore delta yn is equal to yn plus 1 minus yn minus 1 divided by 2. Or what you can do is you can send this to delta yn equal to yn plus 1 minus yn minus 1. Okay, so next also one more, and this can also be written as delta yn is equal to divided by 2. You can, because anyhow you have this one, right? So you can write this as delta yn is equal to delta yn plus by 2 minus delta yn minus 1 by 2. You can write that way also. Okay. Next, this let us consider the second order derivative. You can consider here second order derivative can be obtained by delta square yn is equal to delta yn plus half. Okay, because delta of the delta, difference of difference you'll have to calculate. So delta yn plus 1 by 2 minus delta yn minus 1 by 2. Okay, so that will be the second order difference. So only difference central difference method in the central difference method is you will be considering the next ordinate and the previous ordinate. Okay, that difference divided by 2 you will be doing. Okay, so finally you will be getting these equations. So this is the equation for delta square yn. Okay, remember this equation. So it can also be written as yn plus 1 minus 2yn plus yn minus 1. Okay, so these equations can also be obtained by simply considering this table. Okay, chart. This chart you can consider. So here in the central difference method, both values you will have to consider. Yes, considering the yn highest, and next yn minus 1, yn minus 2, yn minus 3, just like that we were considering, as you can see here. Okay, but and then in forward difference method, yn plus 1, yn plus 2, we were considering highest values. But in this central difference method, you'll have to consider yn lower values as well and higher values as well. Okay, so you can start from yn plus 1, yn plus 3, and like that. And so delta y, first order difference, second order difference, third order, fourth order, just like that you can consider. So you can go on increasing the values here. I mean, increase this side, decrease this side. So you have this chart. Now if you want to calculate actually the two, and you just remember in the chart you will have 2 delta yn for the odd values. Okay, for the even values just you will have no multiplier. So for odd values you will have 2 into delta cube by n, and for even value delta to the power 4, this is even, so no multiplication factor. If in case if there is a delta y to the power of 5, delta to the power 5, then you should have multiplied with the 2. So that's how. So what you do, you have these equations. Okay, 1 and minus 1, and delta square yn will be nothing but plus 1 minus 2 plus 1, and next 2 delta cube yn plus 1 minus 1, and this is actually the mirror image, but plus it will minus it will become. The last one value will be remains plus only. Next delta to the power 4, it will be 1 plus 4 plus 6 minus 4 and plus 4. And only the difference is earlier you used to get 3, but there is no 3 here. Okay, so these values you just need to remember. Now let us get delta yn. Okay, 2 delta yn. So 2 delta yn is nothing but 1 time delta yn plus 1 minus delta yn minus 1. You can see here. Okay, so 2 delta yn is equal to yn plus 1 minus yn minus 1. Okay, so that's what you have to do it. And next the equation delta square yn. If you want to get delta square yn, okay, here delta square yn if you want to get. Okay, so what you need to do, you just see here, delta square yn can be obtained by, yeah, here delta square yn is equal to, you have here delta square yn is equal to 1 time yn plus 1 minus 2 times delta yn plus 1 time yn minus 1. You can see here. Okay, what happened? So 1 times yn plus 1 minus 2 times yn. Okay, minus 2 times yn, right? Then 1 time yn plus 1, 1 time yn plus 1. Okay, next 1 times yn minus 1, 1 times yn minus 1. You can see here, right? So that's how you need to get these equations. Finally, the highest value you can get it like this. Okay, delta to the power 4 yn is equal to yn minus 4 yn minus. Okay, so yn, yeah, this is yn here. You can see here yn, that's nothing but plus yn. Okay, here, yeah, yn minus 4 yn plus 1, next plus 6 yn plus 2. Okay, next this actually it should be plus. Okay, this should be plus plus 4 yn plus 3 plus 4, just plus yn plus 4, yn plus 4. Okay, so that's how we need to get the equation for the fourth order difference by using the central difference method. Okay, central difference method. I think you have understood these concepts. Okay, these are all called as the finite difference methods, right? Thank you.